a few more examples of finishing up with our sum and difference formulas. This time we have that the tangent of A is equal to negative 5/12, with A falling in quadrant 2. And then the cosine of B, now this should be equal to 5/7, but we have B in quadrant 1, okay? So just like we did in the previous video, what we should do is start by getting some right triangles for both A and B, keeping in mind quadrants in which functions are positive. So remember, we have our all students take calculus, okay? And we're only looking at quadrant 2 and 1, okay? Now, we know that in quadrant 1, we know that everything's going to be greater than 0, okay? So that's going to be easy. But in quadrant 2, only the sine function, okay? So we know that the sine of A is greater than 0, which means that the cos of A and the tangent of A are going to be less than 0. Okay, we need those to be able to finish these guys off when we do those. Okay, so the tangent of A, remember the tangent is going to be the opposite over the adjacent. So this is 5, the adjacent is 12. And so by using our right triangle trigonometry and the Pythagorean identity, we could say 12 squared plus 5 squared is going to be equal to our hypotenuse squared. Okay, or if we combine those together, that's going to be 144 plus 25. So that's going to be 169 equals c squared, which implies that 13 is going to be equal to c. All right, so this is for our angle A. And so for angle B, which is going to be a lot easier to work with because everything's positive, we have that the cosine is going to be 5/7. Okay, so remember, cosine is adjacent over hypotenuse. So this is 5, this is 7. And so for us to figure out the remainder of this, we just take 7 squared equals 25 squared plus b squared, right? Not 25 squared, 5 squared, excuse me. I was thinking ahead. And then 49 equals 25 plus b squared. We subtract 25 from both sides. That's going to end up giving us a 24 is equal to b squared. And so unfortunately for us, we get square root of 24, which isn't a perfect square. But remember, 24 we can write as 4 times 6, and that should be equal to not b, but b, not b squared, but b. Right. And so we can write this as 2 roots of 6 is equal to b. Okay, so 2 roots of 6. All right, so now we're all set to be able to work with our double angle formulas for this. Okay, so remember, sine of A minus B. So we're going to look at our formulas. All right, and sine of A minus B is going to be sine cos minus cos sine. Okay, that's going to be sine of A minus B is going to be equal to sine A cos B minus cos A sine B. And remember that we have A is in quadrant 2. Okay, so what that means is that the cos is going to be less than 0, but the sine is greater than 0. Okay, so for the sine of A, that means we're going to have the opposite over the hypotenuse, which is going to be 5 over 13. The cosine of B, we already know, that's 5/7. Okay. And then minus the cosine of A. Now remember, A is going to be negative for cosine, right? And so the cosine of A is going to be the adjacent over hypotenuse, which is going to be negative 12/13, right? And then finally, the sine of B, right? That's going to be opposite over hypotenuse. That's going to be 2 roots of 6 over 7, right? And so when we go to simplify this, we know that 5 times 5 is 25. We know that 13 times 7 is going to give us 91. Right? And then negative times negative is a positive. 12 times 2 is 24. And we have the square root of 6. All right. And so that's as good as we can do with this. We can't do any better to try to simplify it. Nothing factors between 24 and 25 anyway. So that's it. Okay. Cos of A minus B. Okay. Well, that's going to be cos plus sine. Okay. So we go here. We have cos of A minus B. So that's cos plus sine. So we have the cos of A, cos of B, plus sine of A, sine of B. And so we know the cosine of A is going to be negative 12/13. We know the cos of B was going to be 5/7. We know the sine of A. So remember, sine of A was 5/13. And the sine of B, remember, we got that to be 2 roots of 6 divided by 7. Right? And so we multiply through. Negative 12 times 5, that's going to be equal to negative 60. 5 times 2 is 10. We have a root of 6. And then in the denominator, 13 times 7, we know that to be 91. Right? There are no common factors between 60 and 91, 10 and 91. All right. So the only other thing we could do is we could factor out a 10 from the numerator. Doesn't matter. We'll just leave it like this. Okay. Now, finally, we have tan of A minus B. So tan of A minus B that we're trying to find. And so we go into our formula sheet. We have tan of x minus y, tan x minus tan y, 1 plus tan x tan y. So this is going to be tan of A minus tan of B divided by 1 plus tan A tan B. All right. Now, remember, if we go up here, the tangent is negative in quadrant 2. Okay, so, and then in quadrant 1, it's positive. Okay, remember, the tangent is the opposite over the adjacent. Okay, so remember, we already have tangent of A. All right, it was negative 5/12. So we can just plug in negative 5/12. Okay, and negative 5/12. Now the tangent of B is going to be, again, opposite over adjacent. Remember, B is in quadrant 1, so everything's positive. So that's going to be 2 roots of 6 over 5. That's going to be 2 roots of 6 over 5, and then 2 roots of 6 over 5. All right, now we are going to have to do some simplification to this one. All right, so unfortunately, it's just not going to be as nice as we'd like it, but could be worse. All right. In the numerator, we're going to need a common denominator. Okay, and same thing in the denominator. All right, so our common denominator looks like it's going to be 60 for us. All right, and there's no getting around it. We can't just throw this in the calculator because of the square root of 6. All right, so if I was to try to work on these, let's work on these off to the side. So negative 5/12 minus 2 roots of 6 over 5. Right. What I'm going to have to do is I'm going to have to multiply to get to 60. Okay, so I'm going to multiply this by 5 over 5, and this one by 12 over 12. All right, and so what that'll work out to be, after our common denominator, that's going to be negative 25 minus 24 roots of 6 divided by 12. Okay, or divided by 60 in the numerator. Excuse me. All right, so that's going to be negative 25 minus 24 roots of 6 divided by 60. And then in the denominator, that's going to be 1 plus, and then we multiply this across. Okay, let's work on that off to the side as well. Let me erase just a little bit so we can have some room here. All right, so all done with that stuff. Just want to make sure we have some room to work with. All right. So we would have, if we multiply these two together, that's going to give us negative 10 roots of 6 divided by 60. And then we have this 1, which we can turn into 60 over 60. All right, so the denominator is going to become 60 minus 10 roots of 6 over 60. Okay, so this is going to be 60 minus 10 roots of 6 divided by 60. All right, now we're still not done because unfortunately, we're going to have to simplify this expression. All right, so you can see how hairy this gets, unfortunately. We're going to multiply by the reciprocal of the denominator. So negative 25 minus 24 roots of 6 divided by 60. reciprocal, 60 over 60 minus 10 roots of 6. And so fortunately, those cancel out, right? And now what we end up with is we're going to have the negative 25 roots of negative 25 minus 24 roots of 6 divided by 60 minus 10 roots of 6. Now, unfortunately, we do have to rationalize this. All right, so we're still not done, unfortunately. Okay, tangent always gives us problems. So we're going to have to rationalize by multiplying by the conjugate. All right, so now it's going to start getting pretty hairy here. All right, so, but that's okay. We have calculators that can always help us. So 10 roots of 6. All right, so we're going to FOIL this out. I'm probably going to need some calculator help with this. So remember, this is a FOIL problem. So we're going to quantity, 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 quantity. All right. So negative 25 times 60. All right, that's going to work out to be, I think it's negative 1500, but let's verify that. So negative 25 times 60. All right, that's negative 1500. All right. Let's see. It's negative 1500. And then negative 25 times 10 is going to be negative 250 roots of 6. And then negative 24 times 60. Right? Negative 24 times 60. That's going to be negative 1440. Right? And then finally, negative 24 times 10 roots of 6 is going to be a negative 240 roots of 6. Okay, and so if we combine all that, the numerator is going to become negative 1940 minus 490 roots of 6. All right, now let's figure out what the denominator is by FOILing that out. Okay, and remember, interior terms are going to cancel, and then we should be able to divide this out at the end to simplify it just a little bit more. All right, so we're almost done with this. Hang in there. So we know 60 times 60 is 3600. 60 times 10 is going to be 600 roots of 6. This is going to give us a negative 600 roots of 6. And then finally, negative 10 times negative 10 is a negative 100. And then we multiply that by 6. So that's going to be a negative 600. So the denominator just becomes 3000 because those will cancel out, and 3600 minus 600, right? Lastly, we can clearly see that there's a common factor of at least 10, okay? So that's going to be negative 194 minus 49 divided by 300, 49 roots of 6, all right? And I think that's about as simple as we can make this, okay? I don't believe that this is going to have any shared factors, okay? Because I know 49 doesn't have a factor of 3 in it. We could always just try our calculators and do like the math enter for each of these. So might as well just do it one more time. So I'm going to take 194 divided by 300 and then do the fraction for that. So that one simplifies, okay, because that is a common factor. It looks like a 2 in there. But the other one, 49 over 300, I don't think that has a common factor of 2. So I think we're stuck. Okay, so 49 out of 300 is just 49 out of 300. Okay, so unfortunately, we can't simplify anymore. It seems like it took us like 20 minutes just to simplify that. Okay, all right. So I think the ones in the MyMathLab are a little bit easier than this one. Okay, neither of these are too unreasonable on an examination or something like that. Certainly, I don't think this is reasonable for an examination. But just a good illustration of how making sure that we use our algebra correctly is going to be able to help us to go through it. Okay, so we have one more problem in this section, and then we're going to be done with our sum and difference formulas.